In the world of three-dimensional geometry, the perfect cube holds a special secret known as the magic angle. When you draw lines connecting the opposite corners of a cube, known as space diagonals, they intersect at a specific unchanging angle of approximately 70.53 degrees. This is considered a fundamental constant of cubic geometry. Its significance extends beyond the classroom into fields like chemistry and crystallography, where it relates to the tetrahedral angles found in structures like methane molecules. What makes this angle truly magical is its independence from the size of the cube. Whether a cube is the size of a grain of salt or a massive building, the intersection of its diagonals will always yield the same result. This consistency is rooted in the cube's perfect symmetry. Because every side length is identical, any change to the cube's overall size scales its internal paths perfectly, keeping the mathematical relationship between them locked in a fixed ratio. In essence, the symmetry ensures that the internal components of the shape are always in balance. However, this stability is lost the moment we break that symmetry by transitioning from a cube to a rectangular prism. When the side lengths are no longer equal, the angle between the diagonals is no longer a constant. Instead, it becomes a slave to the shape's proportions. By changing even one dimension, you shift the internal geometry, causing the diagonals to either tighten or spread apart. The impact of these proportions is most visible in extreme aspect ratios. For example, if you stretch a shape into a tall, thin pillar, the diagonals are forced to travel a much longer distance along one axis. This makes them appear increasingly parallel, causing the angle between them to close towards 0 degrees. On the other hand, if you flatten the shape into a thin, wide plate, the width begins to dominate the internal space, causing the angle to open up significantly. These extremes illustrate that in a non-symmetric shape, length acts as a weight that dictates the closeness of the paths traveling through its center.